Proof that there exists no integer between 0 and 1. So here let's take an integer n where n lies between 0 and 1. Let's take a more generalized equation where let's take a set S where S contains n belongs to integer, and n lies between 0 and 1. By well-ordered principle, we can say that S must have a smallest element. So here we are saying let's take A as that smallest element of S. So now 0 is less than A is less than 1. On multiplying A on all the three sides, and since we can see that A is a positive integer, we can say 0 is less than A square is less than A. Also, we can now say that 0 is less than A square is less than 1. Since A square also lies between 0 and 1, and since A was an integer, A square also has to be an integer. And hence, A square being an integer lies between 0 and 1. A square also belongs to S. But here we see that A square is less than A. So this contradicts the fact that A is the smallest element of S. So our answer was incorrect, and hence this proves that there exists no integer between 0 and 1.